sample space. Sample space is one of our key words today. We just have kind of a lot of vocabulary today, and that's why our notes are a little bit longer. They really only take up one page, but again, just a lot of talking, making sure we understand we're all on the same page. So, sample space.
I don't think I know one.
All right, sample space is all the possible outcomes. Sample space is all the possible outcomes. Looking for
RW?
yeah, not here.
Right here?
All right, so if I do kind of a bag here, I'm going to make like our brown paper bag that we had yesterday. All right, and in that bag, let's put like 3 circles.
Do I have to?
Yep. Yep. And then let's do a couple boxes. So I'll do a box and a box. Okay. And then we'll do maybe a couple stars. Maybe 2 more stars. All right, so as I take a look at this and I look at my sample space, what I really want to think about is if I reach into this bag and I grab something, what are some options that I could have grabbed? Good, I could grab a star. How many stars are there?
There's 4.
Good, there's 4 stars. What's another option that if I reach in the bag, what else could I grab? Good, a circle. How many circles? 3. And then there was one more option. A square or a box, yeah. And how many boxes do we have? 2. So this is my list. If it asks for a list of the sample space, this would be my list of the sample space. But when I ask what is the sample space, I'm looking for a number. How much is in our sample space? How many objects were there total? Good. 4 plus 3 plus 2 equals 9. So 9 total. So that is our sample space. Is we're really looking at how many options total are there. There's 9 different objects. All right, that brings us to our next definition, which is probability. And when we think of that word probability, what does probability kind of sound like to you? What word might you use in the real world that sounds like probability? Probably, what? Kind of like what's supposed to be? Yeah. So probability kind of sounds like probably, like what will probably happen or what won't probably happen. So probability is kind of like that word probably. Like when I reach into this bag, what would I probably grab?
Probably a star.
Why?
Because there's probably 4 in there.
Because there's more stars than everything else. What won't I probably get?
You probably won't get one.
Good. Probably won't get one of those boxes or cubes. Good. Good, so probability tells us how likely something is to happen. So it's a number between 0 and 1. To represent how likely an event will happen. I'll give you a little bit of time to write that down. That was kind of a long definition. Probability is a number between 0 and 1 to represent how likely an event will happen. A number between 0 and 1 to represent how likely an event will happen. All right, so let's talk about that. If I start at 0, and I'm going to go all the way up to 1. So I'm going to draw this really long line. I would suggest drawing a long line with me. You can't see that. Beautiful. Love that. To go to 1. If something has a 0 chance of happening, or a 0%,
Never gonna happen.
it's never going to happen. If you ask somebody out and they're like, not in a million years, that means it's not going to happen, right?
In a million years it will.
If you're still alive. So 0 means it's impossible. It won't happen. So a 0% chance means it won't happen. So for example, what is the probability that Miss Morel does a double backflip right now?
Ooh, I think that's a pretty good chance, actually.
Is it?
It's
Can't do it.
50%.
I've never done a double backflip standing or on a trampoline. I can do it off a diving board, but there's no diving board here. So 0%.
So that means you can still do it.
Yeah, but if I do it right now,
Oh, yeah.
no, impossible. All right, 1, on the other hand, is really what percent? 100%. So 100% means that it's guaranteed. It's for sure. Okay, so the word we like to use for that is certain.
By the way, how did you win the competition?
We did pretty good. We were 4 points away from making nationals, so it was a little disappointing, but he did really, really good.
Wait, what is national?
What is nationals? It's where you go against like the top 26 people in all of America.
Dang, if
So.
you were like that good.
We were 4 points away. Next year we'll make it, maybe.
Yeah, next year.
All right, so
Will be 70%.
1 means 100%. So for example, what is the chance that you are in period 2 right now?
Ooh, 100%.
100%. Are you here?
No.
What? You are here. It's 100%. You're already here, right?
It's a figment of your
Okay.
imagination.
That's possible. All right, what would be right in the middle between 0 and 1?
50%.
50%, or what fraction?
Probably.
What decimal would be between 0 and 1? 0.5. How would I write that as a fraction? 1/2, and then as a percent?
0.5.
No, 50%.
Oh,
That's all right. All right, so if something is 50-50, or it's a 50% chance, what does that mean? How could we describe that in words?
Likely.
It's likely. It's right in the middle, though.
I use the word probably.
So if I flip a coin has 2 parts to it, right? It has heads and tails. I don't have one on me. I usually do. Okay, heads and tails. When I flip a coin, will it probably land on heads, or would it probably land on tails?
Oh, we don't know.
We don't know. It's half and half, right? So it's an even chance, or equally likely. Sometimes we say that. So it's an even chance.
Did you know I swear, I always land on tails.
Do you?
Yeah, I swear, I always land on tails multiple times.
That'd make it easy for a game. All right, so then if it's between 50% and 100%, so let's say it's an 80% chance of rain today, does that mean it will probably rain or it won't probably rain?
It probably will.
It probably will. So as we go 50 to 100%, that turns into our likely. It probably will happen, but we can't guarantee it.
So like scale
But between 0 and 50%, on the other side of that, it's unlikely. Good, we use that prefix un, which means not. So it's not likely. It might happen, but unlikely. All right, how are we feeling? Making sense?
No.
No?
Yeah, I still need a few more examples.
Yeah, well, we have a couple more examples. So does this part make sense with the percents?
Yeah.
And the decimals and fractions? Good. All right, so last part here is we're going to say P. We use capital P and then an capital A.
Yay.
We put that A in parentheses. And the way that we read this is we say probability of A. All right, so when we see that capital P tells us probability. And then to find the probability, we do how many times A happens, so the amount of A. And we write it as a fraction over our total amount. All right, you guys are crushing this. Feels a little long today, I know. You guys are also really, really quiet, except for Joelle. Thanks for talking today, Joelle. You're making class a little less boring.
Because you're boring.
I am boring.
I'm joking.
All right, so we're going to do a couple examples here. I'm going to just draw a line across to show that this is now kind of the end of kind of our information. This is where we're going to find those definitions. It's where we're going to find those examples of those. But now we're going to move on to an example, and our example is going to have to do with rolling a dice. Now, in Webster's dictionary, they just changed it a couple years ago. They said dice is okay to say when we're talking about just one. Before, when we talked about just one, does anyone remember what the singular version was? Die. So it was just a die, but it is okay just to say dice now. The dictionary changed it. They're like, die is stupid. We're going to do dice. Everyone called it a dice anyways, right?
I like that.
All right, so if I look at my sample space, if I wanted to list my sample space, what options do I have when I roll a dice? Yeah, when I roll it, we get those numbers. So we have 1. We have 2. 3. 4, 5, and 6. So how many total are there? There's 6 total options. So if I asked you, what is the sample space, you would say 6. If I told you to list the sample space, you would say 1, 2, 3, 4, 5, 6. All right, we're going to do 5 examples here. So as we work, if you have room for 5, try and space that together, or you might have to go to the next page. Okay? All right, first what we're going to do is our probability of rolling a 5. So I'm going to say P, and then in parentheses, 5. So P stands for probability. And then in the situation that 5 means that I'm rolling a dice. So what's our probability of getting a 5? So for probability, we want to think about how many times that happens over our total amount. So how many 5s are there on this regular dice?
1.
There's 1 5 out of how many options?
6.
6.
Got it?
Well, we're going to make it into a decimal. So for a decimal in Desmos calculator, we can just do divide. So 1 divided by 6. We get 0.166666666666667.
Unlikely.
So how do we show that 6 repeating? Does anyone remember?
Oh, yeah.
Good, that line above the 6. Because that 7 isn't really there. Whoops. That 7 isn't really there. It's just there because the calculator had to stop. Does anyone remember how to change a decimal or a fraction into a percent? Good, you can move it 2 places to the right. Or in our calculator, we can multiply by 100 because percent means per 100. So let's just round to the nearest percent. Do we want this to be 16% or 17%?
Probably like 17.
Yeah, that 0.6 tells us to stay the same or round up.
Round up.
Round up, so 17%.
Not like that.
So if I had to categorize this, what is the probability of rolling a 5? Is it impossible?
No.
Unlikely? Even chance? Likely or certain?
Unlikely, just like the other one.
Why is it unlikely?
Because it's 17%.
Good, it's a small chance and it's less than
Less than
half.
55 and 50.
Good, less than 50%. 50% is where it changes from unlikely to likely once it hits over that 50%. Good. All right, what about a probability of an even number? Probability of an even number. So first we need to remember what even and odds are. Remember, it's like skip counting.
Yeah.
Evens start at which number when we start skip counting?
0.
2. 0 is not even or odd, so 2. And if we skip count, it'd be 2, 4, and then 6. And it would keep going, but on our dice, do we have an 8?
No.
Nope, so just 2, 4, 6. So how many even numbers do we have?
3.
3. Out of how many total?
3.
On the dice.
Oh, on the dice, my bad.
6 options, good. So our probability would be 3 out of 6. Okay, but we do want to simplify that if we can. Does anyone know how we can simplify 3 out of 6?
Going to Desmos.
Yep, 1/2. Yeah, or you can go into Desmos, type it in, and then we hit that little circle button. Let me get 1/2.
It's 50 chance because technically it's 6 and then you just take a 3 out. It's going to be 50.
You got it. And 1/2 as a decimal is 0.5. When we do decimals, always make sure you put in that 0. Otherwise, your reader doesn't know if that's supposed to be a decimal or not. Sometimes it looks like a smudge. Don't just write 0.5. Don't do it. All right, and then what's 0.5 as a percent?
50%.
Good. Some people go a little fast with this, and they want to write 5%, but 0.5 is really 50% because we're moving it over 2 times.
Good job.
All right, so on our scale, with 50%, is this impossible, unlikely, even chance, likely, or for sure? Even chance. Another way to say that is equally likely. I'm going to write that here just so that we have it on our notes somewhere. You might see that on your practice sometime, equally likely. It's the same thing as even chance, 50-50.
I think this is another example.
We got one more.
One more?
2 more.
2 more? I don't want to do 2 more.
Okay, well, this next one's kind of important. And then the last one you could probably skip if you really want to, but the last one's the easiest one, so. But this one don't skip. This next one's really important. All right, not last one, second and third one. Probability of not 3. So probability of not getting a 3. So when we say not 3, that not tells us that we want anything but a 3. So what are some options that we could get that's not a 3?
1, 2, 4, 5, 6.
Good. 1, 2, 4, 5, and 6. Those are all good numbers.
It really gives me not to say 3.
Okay, as long as we can't have 3. So how many numbers on the dice are not a 3?
4. 3, 5.
5. So 5 out of how many numbers total?
6.
6 are not 3s.
Yeah, we hate 3 around here.
Do we?
Yeah, we do.
Alright, so in my calculator I'm going to do 5 over 6. If I don't know if it simplifies, I can hit that fraction button. It stays the same, so I know that that's simplified. We get 0.83333333. So we can write that as 0.83 repeating. And then if I need to write that as a percent, we can either move that decimal over 2 times. If that's hard for you to visualize, you can always write times 100. So should we keep that at 83% or around to 84%?
84. Actually, not 83 because all of the other numbers are, lower than 5.
Yep, you got it. So 83%. All right, so likely, unlikely, impossible, even chance, or certain. Good, this one's likely. It will probably happen.
Okay.
So if I roll the dice right now, it's probably not a 3. Could it be a 3? Got a 1. Let's try it again. Oh, lost. There you go, 6. So probably not a 3, but it could be a 3. All right, last one. If you have a little bit of space here, just try and fit it real quick. Probability of 14. Just sneak it in there. This one won't take very much space. Probability of rolling a 14. Now some dice have a 14 on it. Our dice that we're using today, does this have a 14? No. So how many 14s are there? 0 out of 6. What's 0 out of 6 really? 0. What's 0 as a percent? 0%. So what kind of probability would this be?
0. Impossible.
Impossible.